Mr. Berg teaches a mathematics class with 15 students. In this class there are 6 female students and 9 male students. Each day, Mr. Berg randomly chooses one student to answer a homework question. In the first month, Mr. Berg will teach his class 20 times. A. Find the probability he will choose a female student 8 times. So, let x be a random variable number of female students chosen out of 20 times. Hence, x is distributed binomially. N is 20, total number of trials, and probability. What is probability? Probability to choose female, because x describes number of female students chosen. So probability to choose a female student is, since there are 15 in total, 6 female, 9 male, so probability it will be just 6 out of 15. It can be simplified, but it doesn't matter because we will calculate it with the calculator. And we need number of female students chosen to be exactly 8. So we need just calculate probability that x is 8 under x is distributed binomially with these parameters. So we use a calculator, and we need just, since it's in a single point for a single value of x, we choose binomial PDF. It's not correct to say at a single point, it's just for one value of x specific, not less or equal or greater or something like that. So we use binomial PDF if we need to calculate that x is one value. So number of trials, it's 20, probability it's 6 divided by 15, and x is 8, and just enter, and we get the required answer. It's 0.180 to 3 significant figures. The next part, the head of year, Mrs. Smith, decides to select a student or at random from the year group to read the notices in assembly. There are 80 students in total in the year group. Mrs. Smith calculates the probability of picking a male student 8 times in the first 20 assemblies. Is this value correct to 6 decimal places? B. Find the number of male students in the year group. So this information may be a bit confusing, but it will be not given directly that it's binomially, and you should deduce that the situation can be described by binomial distribution, and let y be a random variable number of male students chosen out of 20 assemblies, and hence y is distributed binomially. Total n is 20, total number of trials, and probability is unknown here, and since we need male, and there are 80 students in total, and let number of male students be x, so probability is x over 80. Notice that it's another x, it's not this x from A. Don't get confused. And it is given that probability that y, number of male students selected 8 times, is this value. So it is given probability that y is 8 is equal to this value, 0.15, and so on. And we need to find x. How to do that? We actually get an equation that probability is equal to some value, and it will be more useful to move everything to one side. So to move this value 0, 15, 33, 57 to the left and equate it to 0, and do as usual, consider the left hand side as some function, plot a graph of this function, and since we move everything to the left, another function on the right hand side is y is 0, it's x-intercept, and if we consider a graph we need just x-intercept the zeros. If you consider some function to the left, some function to the right, you need to plot the left hand side, the right hand side, and consider point of intersection. But if we move everything to the left, we plot or consider only one function, and we use a calculator, and y is probability that y is 8, so it's a binomial, so we choose second. So we choose distributions, binomial PDF, because it's for a single value of x, binomial PDF, and number of trials 20. Probability is x. We always use x as unknown parameter, x divided by 80. In your equation it may be absolutely any letter, but in a calculator unknown value it will be always x, it's here, and x is 8, and enter. And since we consider this equation, it's this probability that y is 8 and minus 0.153357, and we can consider graph, but it will be more useful to consider just table, and we need value y to be equal to 0, and we need x, because x is directly unknown value. So let's consider, or let's start. You can see that I want to show just from 0. We can see that 0, 1, 10 values are not very close to 0, but we need very close to 0. Continue, and we can see that at x is 37, this value it's negative, but multiplied by 10 to negative 7. It doesn't matter that it's negative, it means that it's negative 0, 6 zeros and 3, so it's approximately 0, and it doesn't matter that it's negative or positive, so it's the closest value to 0. We cannot get just 0 because probability is rounded to some value of decimal places, so we choose just the closest value to 0, and it's 37. So according to our notation, x is this x, so x is 37, and it's the required answer. And it's all for this question.